All right, this is section 5, estimation. This is a continuation of what we did in section 4 with sampling. Estimation issues come up when we want to know something about a population, but it is costly to sample that population, or at least sample it in full. Some of the things we might want to estimate are inflation or unemployment rates, outstanding balance or credit cards, number of hours worked per week, percentage of households who view a particular television show. Businesses use estimation techniques all the time to get an idea of the customer needs and wants. Governments use estimation techniques when they want to sample a population. Political leaders use estimation techniques to decide political polls. And if we remember in section 4, we had this population, and we would sample from the population, assuming that the sample is random. We'd measure something. Now, we're always going to be measuring either the sample mean or the sample proportion. We're not going to look at any other statistics for the sections on out. And then once we've measured that statistic, we make an inference about the population. Now we know that that value, that inference, is going to be off. It's going to be wrong. But that middle point in that scale is, let's say it's a mean, is a point estimator. It's a single number that estimates the exact value of the population parameter. So if we want to know something about the population mean, we would take the sample mean and we would say, okay, the sample mean is this within this limit. And the limits is the interval estimate, the range of values that will likely contain the population parameter with some degree of confidence. We call that the confidence interval. The confidence interval has a lower bound, lower confidence interval, and an upper bound, upper confidence interval. So interval limits are the lower and the upper values of the interval estimate. The confidence interval is the entire range from the lower limit to the upper limit. So we would say we are confident within this probability that the true or population parameter would fall within these limits. The confidence level is the degree of certainty that the interval will include the actual parameter. Now we're going to limit the degrees that we're looking at to 90%, 95%, and 99%. We could look at other confidence levels or degrees of certainty, but these are the most commonly used. In fact, 95% is probably used most often. Now the accuracy is that estimation error. So on the top hand side, we know that it will be X bar, or the sample mean, plus the estimation error. To get to the lower confidence interval, we would subtract that estimation error. So this estimation error is sometimes called the maximum likely error. It's given the letter E. This is the possible difference between the sample mean and the true population mean, or the sample proportion and the true population proportion. So we would say that this confidence interval is determined as the sample mean or the sample proportion plus or minus the error. So let's take a look at an example of how we would calculate the confidence interval. So in this example, we have a startup company. It is developing a new consumer product unlike anything which is currently existing in the marketplace. The research and development group has developed a functioning prototype that they will be test marketing in a focus group. Focus group is a small group of individuals that they call in and ask them questions about what they think about the product before they actually roll the product out. So among other questions about the product, the focus group participants are asked to state what is the maximum amount of money they would be willing to pay for this product. Now, the company really wants to know what the public or the entire population would pay. but they don't have the resources or the ability to do that until they've released the product, and then they already need that price on it. So they're trying to estimate this price. So they bring in 36 respondents. We find that the sample mean is 28.6 with a standard deviation of $2.4. So we want to know, what is the average price that the target market is willing to pay? Now the sample, or the 36 individuals that we included in our focus group, is willing to pay $28.60. But the inference about the population mean is going to be something different than $28.60. Inferential statistics allows us to create that interval. So the simple point estimate is $28.60. This will be fine if we want a single descriptive estimate of the population mean, but we know that due to sampling error, this is probably not exactly true, but it may be a good enough guess. We can draw a confidence interval around this point estimate. Point estimate is not enough if we want to be more accurate in our estimate, and we are going to be making some strong claims that involve statistical inference. So we know that the sample means vary due to sampling error, but how can we use this fact to develop a confidence interval? So realize that the sampling distribution now takes the center stage, since it is the distribution that tells us how much variation there is likely to be in the sample means with the specific value of n and a population standard deviation. So we're going to be using standard error. And remember, as a review from section 4, standard error is the standard deviation divided by the square root of n. So the general concept: assume a normal distribution, sampling distribution, with a mean and a standard deviation or standard error of no, that was cut off there. Standard error is the standard deviation divided by the square root of n. So if we calculated a z-score, we would say that 95% of our distribution here is contained within 2 standard deviations. So we're going to go +2 on the right-hand side and -2 on the left-hand side. So what is 2 standard deviations? Well, if we want to be 95% confident and we look at the z-tables, we find that we're not exactly 2 standard deviations. We can see that we're almost 2, but using a standard z-table, a standard z distribution, to get 95%, we need to be within 1.96 standard errors. So we need to take the standard error and we need to add it to the mean and subtract the mean, 1.96 times the standard error, and that would give us that 95%.